So as we all seen in our yesterday's class, what is the experimental setup of Rutherford? So this is what is the experimental setup of Rutherford alpha particles scattering experiment. And what do you mean by alpha particles, everybody? Simply, if you want to say alpha particles, what does it mean, everyone? Alpha particles. What is the name of the alpha particles? He?
He2 plus.
2 plus.
He2 plus. That is what. So what is the mass? Mass of this one, how much it is? 4 AM.
4U.
Understanding? 4U or 4 AM. Understanding what is the charge? Charge is how much?
2 units.
2 units. 2 plus units. Okay. Yes. So now Lakshana is having doubt in yesterday's second point. What is your second point? I don't know. So she's saying a few alpha particles were deflected with small angles and few with the large angles. Yes, Lakshana, we are going to discuss now. So let us start with the experimental setup. So alpha rays scattering experiment. So we are having, this is the source of alpha rays, source of alpha particles. So they will be passing through the narrow slit and they are falling on the gold foil whose thickness is about how many nanometers? Everyone, yesterday we have studied about what is the nanometer size thickness? I think
210.
120. Am I right? 120 nanometer. That is what? Almost equals to how much? Everybody. 1,000 atoms of gold. 1,000 atoms. That is what approximate size of gold thickness. Extremely small. So in this, what will happen? The alpha particles which is striking, Mr. Rutherford thought that many alpha particles will stuck in the gold foil as their mass is heavier. But surprisingly, he observed the results that most of the alpha particles are passing through the, you can notice it here in this figure. So schematic molecular view of a gold foil. So this is only in our book also. Majority of the alpha particles is started passing through the gold foil and it is appear on the screen. What is the screen we used to call it as? The screen is coated with something. Anybody?
Zinc sulfide.
Yes. Zinc sulfide. Yes, it is not 120. I think, what is that, Nivedan? Padma is saying 210 nanometers. Very good. So it is 210 nanometers. Sorry for that. Okay. So now this coated with what, everybody? It is coated with a, yes, please.
Zinc
Zinc
sulfide.
sulfide.
Zinc sulfide, ZNS. So what is the use of it? Zinc sulfide will scatter the alpha particles. So that is what is the use of zinc sulfide. Okay. So now majority of the alpha particles is passing through the gold foil without any deflections. So that is what is the first point. So majority of the alpha particles, what is the observations of Mr. Rutherford? Everybody already have written in our classwork. So the first observation is most of the alpha particles are passing through the gold foil without any deflections. Are you all clear, everybody? Second observation, few alpha particles, you all can see, few alpha particles are deflecting in a small angle and few alpha particles are deflecting in a greater angle. Okay, that is the second point. And third point, out of 12,000 alpha particles, out of 12,000, it is taking the what, everybody? 1 out of 12,000, it is taking what, all of you?
Rebound.
It is taking the rebouncing. So there is no, here in this figure it is not mentioned. So let me mention back. So 1 out of 12,000, it is rebound. What do you mean by rebounded? It is just turned back in the what? Turned back in the same direction. Afternoon, I will check the classworks. Let me see how many of you are learning. Alfin, are you writing the classwork? I want know the things, truth. Yes or no? Not writing, not going to work out, I'm saying. Remember, from March, mostly from the March middle, we are going to start the 10th class. If you are not ready to work, I don't have any problem. You can leave. If ready to work only, you can continue. So that's what I'm saying now itself. So concentrate. Mari, are you audible? So see that. So these are the three observations made by him. What is the first observation, everybody? Repeat it. Majority of the alpha particles will goes in a straight line without any deflection. Few particles will deflect less and few particles deflect with the large angles, smaller angles and larger angles. And last one out of 12,000 will turn back in the same direction, rebound back in the same path. So this is what is the observations made by the Rutherford. Anybody having doubt? Do you all written, guys? Please let me know. Kishore, Mr. Lingesh, Nivedan. Now,
Yes, sir.
repeating everyone. Conclusions derived by Rutherford. I will say you have to remember, and you are making that conclusion or not, you tell me. See, instead of learning, learn from the observation. That is what is the way of learning style. Otherwise, it is impossible to score good mark in the 10th and 12th, whatever it is. Now, so first point, what is the first observation? You repeat it, all of you. What is the first observation? Everybody?
Majority of
First
the alpha
observation made
particle.
by that. Yes, please.
Majority of the alpha particle passes through the gold foil without deflection.
Now, I will first conclusion from this. Now, listen, everyone. Suppose now 1,000 people are passing. 1,000 people are passing in a particular thing. So imagine there is in front of there is a wall for you. Now, most of the people are able to pass freely through them. Means in the sense of inside fully it is empty space or it is fully filled with any material. Anybody? You are able to pass easily means it is an open space or it is a closed space. Anyone?
Open.
Open
Space.
space. That is only. Do you all understand, everybody? The first observation, first conclusion. So keep reading neatly, everyone. So what is the first conclusion made? So conclusions derived by Rutherford. So please mute yourself. So what is the first conclusion, all of you? Speak. So as the majority of the alpha particles are passing freely, so we can say that most of the space in an atom is what? All of you. Yes, please. Most of the space in an atom is what, guys? Is filled with anything or it is empty? It is empty. So that is what it is. All of you clear, everybody? Yes, please.
Yes, sir.
Yes. Why we are saying this point? Anybody can tell? Because majority of the alpha particles passing through the gold foil with deflection or without deflection?
Without deflection.
Without deflection. That is the one. So gold foil is a solid throughout and made up of atoms, but atoms are not solid throughout their volume. So it was concluded that most of the space in an atom is what? Most of the space in an atom is what? Everybody? Empty. Do you understand, everyone? Clear, Amma? Please respond, guys. Everybody? So, what I'm trying to say, gold is a solid. Gold is a solid. Continuously, it is a solid. It is made up of atoms. So, throughout the volume, gold is a solid only. But atom is not a complete solid. The volume of an atom is not complete solid. Do you all understand, everybody? So inside there is an empty space. That is why majority of the alpha particles are passing through that. That is what you have to remember. Okay, guys? Everybody? Please respond. So gold foil is the solid throughout. It is made up of atoms, but atoms are not solid throughout their volume. Understanding? If the atoms are solid throughout the volume, what will happen? Majority of the alpha particles will bounce back. So they are passing. Many alpha particles are passing freely. So it is reflecting that it is filled with the empty space. Is it okay, guys? Are you understand? Nivedan? Engage? Yes? Next.
Yes, sir.
Second one. As we know, we already studied magnets. Same charge. For example, north and north pole will show attraction or repulsion. Everybody.
Repulsion.
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 Same way, south and south will shows repulsion. Am I right, Mr. Sam? Are you there? So it will shows repel.
Yes, sir.
They will repellent each other. Same way, we are noticing some particles are deflecting either small angles or large angles, or bouncing back also. So actually we are sending what particles? Alpha particles. Alpha particles means what? They are positive charge or negative charge? Everybody. Yes, please. They are positive charge or negative charge. Alpha particles are what charge, guys? Positive charge. Am I right or wrong? Please respond. All of you. So the particles which are passing through the center are closer to the center. Only they are showing the deflecting. Only they are showing the deflecting. Only they are showing the bouncing back. So means in the sense of the positive charge is located at the where, everybody. From the deflections we can notice it. So there is a positive charge which is located at the where, everybody, which is located at the center of the atom. So that is why whatever the alpha particle is trying to strike or passing through that center, they are showing the deflection. They are showing the deflection or they are bouncing back. So that is what the second observation. From the second observation, few particles are showing the deflection in a small angle. Few particles are showing the deflection in a large angle, because we all knows that same charges will shows attraction or repulsion. You say means it will be very fine. It will be same size. What will happen, everybody? Attraction or repulsion?
Repulsion.
Repulsion. So
Repulsion.
that is why whatever the particles are trying to strike the same charge, that is what at the center. So they are showing the deflection. So from that they understand and they made a conclusion that second conclusion. What is the second conclusion, everybody? Positively charged nucleus. Positively charged nucleus is at where? Everybody, at the where it is located? All of you, at the center of the atom. At the center of the atom. So how he can conclude? How he can conclude this point? Anybody can tell? Based upon the second observation. What is our second observation? Alpha particles are what particles? Everybody. Alpha particles are positively
Positive.
charged, and we know that same charge will shows attraction or repulsion. Same charge.
Repulsion.
Repulsion. So by the observation that some alpha particles rebound, some alpha particles deflected from their path. So from that, Mr. Rutherford concluded that the central part of the atom, a small region, which is very small region of the atom, is positively charged, is concentrated. That is the part he has called it as. What is that part he has called? Which is located at the center. That is why it is called it as, what is to call, guys? Nucleus. That is what you have to remember. I hope you all understand. Anybody having any doubt, let me know. Clear? Agalya, Kavya, everybody? Yes, please.
Yes, sir.
Yes. Next.
Yes, sir.
Now, all of you again read second point, observation. What you have read second point? Second point, everybody read. Again read second point, all of you. Observation.
Few particles would deflect with small or larger angles.
Small angles and few with the R not, Padma. Few particles will deflected with the small angles and few particles with the large angles. So,
Yeah.
very few only it is deflecting. Whatever the angle, small angle or larger angle, means in the sense of the size of the positive charge is very small or very large. Everybody. Very few only deflecting. So from that I can say that what? The size of the positive charge is very small or large. Everybody.
Very small.
Size. That
Yes.
is what? Yes. The very small size of nucleus. Sir, how much it is? You remember, the size of the nucleus is extremely smaller as compared to the total size of the atom. So for example, if we consider this is the atom So this is the atom. Example I'm saying. Any atom. The size of the nucleus is, remember, 1 lakh times it is smaller than the size of the atom. Please write it. The size of the nucleus is, it is found that experimentally, the radius of the nucleus, write it. The radius of the nucleus is 10 power 5 times less or more, everybody. 10 power 5 times smaller than that of an atom. I hope you all understand, everybody. So how much time it is less, everybody? 1 lakh time. Do you understand? For example, if I take radius of nucleus, radius of nucleus is 1. If I take for example, then can you tell me what is the radius of atom, everybody? Radius of atom, how much ra? Mathematics, anybody? Nobody is there.
10 lakh times.
10 lakh times or 1 lakh time?
1 lakh times.
1 lakh. So if you consider radius of atom is 1 lakh, then radius of nucleus is just 1. That is what you have to remember. I hope you all understand. Everybody, Mr. Gokul, Kishore, Mari, any doubt, please let me know. Do you all understand, Amma? Yes? That is what. So please write it. Clear, everybody? Prithvi?
Yes, sir.
Yeah. Make it. Understand, Danishka?
Yes, sir.
Do it. Next point. Next, you see that all of you, if you all observe here, the rebounding, third point to read, everybody. Rebounding, third point to read.
1 out of 12,000 particles.
One out of 12,000 just turned back in the same direction, means rebounding. But actually, I told you yesterday and today also, what Mr. Rutherford expected when he is passing the alpha particles, what he expected. Anybody can tell? What he expected, as the mass of the alpha particles is heavier, they will stuck in the gold foil. Is it right or wrong? All of you? Yes, please. Yes or no, guys? He expected that only correct. They cannot be passed. They cannot be deflected much and they cannot be passed. But if you notice here, if the alpha particles are bouncing back, one out of 12,000, it is bouncing back in the sense of, now you tell me, the nucleus is more denser than these particles or less denser than particles, alpha particles. Everybody? So that is what is the fourth point. Remember, the density of the nucleus is extremely high. The high density, that is why we can say whole mass of the atom is located at which point? Whole mass of the atom is located at the which point, guys? At the nucleus only.
Center.
So at the center, that is what nucleus. So high density of nucleus is extremely high. So please write it. The nucleus has very high density. That is the reason 1 out of 12,000 particles. What will happen? It will be bouncing, rebounding on the same of calculations. And he has been found that again, remember, the size of the nucleus is, even experimentally, it has been found that the size of the nucleus is 10 power minus 15 meters, and the size of the atom is 10 power minus 10 meters. This is the size of the atom, and this is the size of the what? Anybody? Size of the nucleus.
Yes.
Okay, so that is what. So that is why it has been proved that by rebounding of alpha particles, it does not allow the alpha particles to pass through that. So on the basis of the calculations, he found that the nucleus size of an atom is 10 power minus 15 and size of the atom is 10 power minus 10 meters. 10 power minus 10 meters. That is what? How many times the nucleus is smaller? How many times the nucleus is smaller? Everybody. 1 lakh times it is smaller than the atom. That is what it is indicating. So anybody having any doubt? So these are the four conclusions made by Mr. Rutherford from this experiment. Call it as alpha ray scattering experiment. So anyone having any doubt, you can ask me. So till here, finish it just 1 minute. So you can revise yourself. If you have anything doubt, ask me. Otherwise, we'll go with the next one. That is what? Rutherford atomic model. Okay. So what is the model he made from this? That is what we are going to discuss. Okay. So do it. Next. So one important point I will say, you note it. You might be asked me this question before also, but now I am asking you. Why Mr. Rutherford choose the gold foil? Why can't any other material? Anybody? Answer please.
It has high malleability.
Malleability, that is secondary. And another thing is, the size of the gold atom is larger than other atoms. That is also one of the reason he has been taken. So please remember that. Moreover, the size of the gold atom is larger than other atoms. The size of the gold atom is larger than other atoms. Understand all of you? Everybody? Yes, please. Do it.
Yes, sir.
Yeah. Do you understand, Prithvi? Sam?
Yes,
Any
sir.
doubt? Any doubt in this? Ask me.
No, sir.
Okay. Next, keep heading. Mari, clear?
Yes, sir.
Write it. So next one. So after this, we are going to study what now? Everybody. So what is the model? He has been made. That is what? Rutherford atomic model. So keep heading, everyone. Rutherford's atomic model. My everything is important. In exam, they can ask anything. If they ask observations, you have to write observations. If they ask conclusions, you have to make conclusions. If they ask model, you have to write the model. So now we are going to study that. So this is the D. Next segment, we are going to study. So that is what? Rutherford atomic model. Okay. So keep ready. So what is that? You tell me first, everybody. So let us start with that. So remember, after the failure of Thomson atomic model, so Rutherford proposed a new structure of an atom based upon the experiment. What is the experiment? Rutherford's scattering experiment. So in 1911, year also very important, 1911, the Rutherford gave his nuclear model of atom, but after the discovery of neutrons, when the neutrons is discovered, 1932, see that 1911, Mr. Rutherford formed an atomic model. Up to 1932, nobody knows there is another subatomic particle. What is another subatomic particle, which we used to call it as, all of you? Yes, please.
Neutron.
Neutron.
Neutrons. Again, this Rutherford model is revised. So we are going to study that again. So the main characteristics of this structure is the first one. So regarding nucleus. So first point is mass concentrated in where, guys? More denser at the nucleus only. So that is why entire mass of the atom is located in where? All of you. Is located at nucleus. So that is the first point you have to remember it. All of you understand? So the total mass of the atom is concentrated in the nucleus of the atom, and that nucleus what is the charge? Everybody. What is the charge of the nucleus? All of you. Yes, please. What is the nucleus? What is the charge of the nucleus, Amma? Positively charged.
Positive.
Okay, positively charged protons. That is what you have to remember. Okay, so that's the first one. Mass concentrated in nucleus. Mass concentrated in nucleus. Make it. And you remember the Rutherford atomic model? It is the improved model after discovery of neutrons. So after discovery of neutrons means at the nucleus, along with the protons, some other also will be there. Who is that, guys?
Neutrons.
Neutrons. That is you have to remember. Okay, guys, everybody? Yes? Make it. Completed? Second point. Now, if you see this one, all of you, as it is, electrons are revolving around the nucleus, you will, by seeing that, you will remember some general natural phenomena which is taking place in our surroundings. What is that, guys? Anybody? Yes, please. In our surroundings, there is a system which we used to call it as. Any one of you?
Solar.
Solar system.
Solar system.
Yeah. Abhiram is having one doubt. What is less? So the size, space, and the shape of the atom differs on the type of matters. Yes, sir. Yes, Abhirami. Different elements have different size of atoms, different space, and different things. Everything. Okay, Abhirami.
Okay, sir.
Clear, everybody? All of you? Understand, Amma? So now, so Mr. Rutherford, this is what is the Rutherford nuclear model of atom. So please note this. This is the what? Rutherford's. This diagram, if you want to speak. This is the what? Rutherford's. This is exactly you can take. This is the Rutherford's nuclear model of atom. So Mr. Rutherford thought, so positive charge is located at the center, that is what is the nucleus, and electrons are revolving around the nucleus. So these electrons are revolving around the nucleus. It is similar to the something. Anybody can tell? It is similar to the whom? Solar system. Understanding all of you? So that is why he has considered as planetary electrons. Electrons are revolving around the nucleus like a sun. Like how the planets are revolving around the sun, the same way. So that is only the second point. So what is the second point of Rutherford atomic model? Planetary electrons. Planetary electrons. So what does it mean? So the electrons are revolve around the nucleus in a well-defined orbits or circular paths, just like how the planets are revolving around the sun. So that is why Rutherford called these electrons we can call it as a what? Planetary electrons. So right, the electrons revolve around the nucleus in a well-defined orbits, like the planets revolve around the sun. Like planets revolve around the sun. So that is why these electrons, we call it as a planetary electrons. That is the second point. Third point. Positively, what is the charge of the nucleus? Everybody, positive charge or negative charge? Only rebounding. Rebounding only takes place when it is striking at the center. That is what? Deflecting or rebounding. So that is why, what is that? Nucleus charge. Everybody. What is the charge of the nucleus, guys?
Positive.
Positively charged nucleus. That is the third point. Positively charged nucleus. Third point. The nucleus is positively charged. The nucleus is positively charged due to the presence of whom? Due to the presence of whom? Anybody? Because of whom it is a positive charge? Due to the presence of
Protons.
protons. Next, fourth point. Fourth point. What is the size of the nucleus? Very small or very large? All of you.
Very small.
Yeah, small size of nucleus. How much small it is compared to the atom size? How much it is small? Everybody.
1 lakh times.
Yes. So radius of nucleus is to radius of atom. If you have been taken, so radius of nucleus is 1 time, means radius of atom is how many times? 1 lakh times it is bigger. So that is what. Next, electrons are present stationary or they are revolving around the nucleus. Everybody, they are revolving around the nucleus. They are not at particular place. Continuously they are moving in a particular path. That is what is the next. Revolution of electrons in an orbit. Revolution of electrons in orbits. Okay, so this point will be help us for next model. That is what Bohr's atomic model. Okay, do it. The electrons are not stationary. The electrons are not stationary. Stationary means what? Everybody, rest or at a stagnant position. The electrons are not stationary, but revolve around the nucleus, revolve around the nucleus in specified path. What is that path? Call it as. Anybody can call? Gokul. Specified path. What is that? Call it as. Anybody? Which are call it as Earth revolving in a what orbit? Orbit or the shell, we used to say orbits. Earth revolve around the sun in a particular orbit. Same way here, electrons revolve around the nucleus in a particular orbit. That is what you have to remember. Is it okay, guys? Everybody? All of you? Yes, please.
Yes, sir.
Yeah. Now there is a concept of physics also here. So that is what centrifugal force. Do you all remember I have taught you centrifugal force? Everybody?
Yes, sir.
Yes. So that is what. So here, same way, the electrostatic force of attraction is present. The force of attraction which is present between the electrons is called it as electrostatic force. So write it. Continuation of the points. The electrostatic force, the electrostatic force of attraction between electrons. Electrons are what charge? Mari? Electrons are what charge?
Negative charge.
Negative charge. And the nucleus is what charge?
Positive charge.
Positive charge. So both will show attraction or repulsion. Everybody. Pradhana, am I audible? That is what. So electrons and nucleus is balanced by what force? Everybody, like Earth is revolving around the sun and planets are revolving around the sun because of some force. What is that force? Call it as balanced by the force. What is that force we used to call it as? We studied in gravitation chapter. Yes, please.
Centrifugal force.
Centrifugal force. That centrifugal force only what force we used to say? Everybody.
Gravitational force.
Gravitational force.
Gravity.
Remember it and do it. Do it, everybody. Understand, Mr. Prudvi?
Yes, sir.
Yeah. Any doubt? Anybody can ask. Clear, everybody? Clear, guys? Write it next. So this is the next one, last one. Atoms are electrically what? Neutral or not? That is the last point of Rutherford. Sixth point. This is from again from J.J. Thomson. He copied from him. So he has said the third point. What is the third point of J.J. Thomson? Look into your notebooks and tell me. Atoms are electrically neutral. Is it right or wrong? The same thing. So what does it mean? Number of protons equals to number of electrons. That is the last point of it. Electrically neutrality. Electrical neutrality. That is what we can say. Equal number of electrons, equal number of electrons